We're going to be working with the law of sines, and at first we're going to just deal with the law of sines, if you will. And we can use the law of sines to help us solve a triangle, find all the angle measures, find all the side measures. We're talking about angles now, triangles, that are not right triangles. And one of the ways we can use the law of sines is if we know angle, angle, side. And that's what we're going to demonstrate here in this video lesson. But let's first think about what the law of sines is. It sets up ratios, proportions. So the sine of angle A over side A equals the sine of angle B over side B, which is also going to equal the sine of angle C over side C. So we got proportionality between the angles and the sides. Now, just for good measure, and probably just to mess us up on this example, we've got a triangle here, RST. Let's call it RST. Well, we know angle R, it's 63 degrees. And we know side R, which is the side opposite, it has a measure of 13. We don't know what the unit is. And then we know angle S, it's 51 degrees, but we don't know the measure of side S. And then we don't know the measure of angle T, and we don't know the measure of side T. Probably if I was working this out myself, I would go ahead and find angle T, which is easy enough to find. But let's get to work here on the sine first. So I can say then, let's go this way, that using this format, that the sine of angle R over side R is going to equal the sine of angle S over side S. And let's plug in some numbers here. Well, we know angle R is 63 degrees, so the sine of 63 over side R is 13 is going to equal the sine of 51 degrees over S, side S, which is what I'm going to use this proportion to find. Now let's do a little bit of cross multiplication, and we're going to try to isolate this side S. And so then we say that S times the sine of 63 then must be equal to 13 times the sine of 51. And then to isolate the S, we're going to divide by the sine of 63. So 13 times the sine of 51 divided by the sine of 63. That should give us the measure for side S. Well, let's see. One of the first things I want to do is check my mode. And I'm currently in radian mode, and we're working in degrees. So I'm going to go hit my mode button and change it from radian to degree. I'm going to quit out of that after that. So I've got 13 times the sine of 51. And we're going to divide that by the sine of 63. And we're going to round this to the nearest tenth. So that S is equal to approximately, I should put my little approximate thing because it is a decimal continuing on out there, 11.3. So we can say here that S is 11.3. Well, that gets that part. Now, what about angle T? And like I say, if I was working this myself, I'd probably go ahead and find angle T because we know there's 180 degrees total in a triangle. And we know two of those. One of them is 51. Angle S is 51. Angle R is 63. And so if I just subtract those, that should give me angle T. 180 minus 51 minus 63. And so angle T is going to be 66 degrees. All right? 66 degrees. angle T. Well, now I can take this information and use to find side T. Now I want to stick with, and when it's sort of setting up my ratios, I want to stay with the things that I was most given, which was angle R. So I'm going to say the sine of angle R, which is 63, over side R, which is 13. Do you see how I'm sticking with what I most know? Equals the sine of 66 over T. And again, we're going to cross multiply so that T times the sine of 63 equals 13 times the sine of 66. And then we're going to isolate T, where T is equal to 13 times the sine of 66 divided by the sine of 63. And that should give us an approximate measure. We're going to round it to the nearest tenth of side T. So let's do 13 times the sine of 66. And then we're going to divide that by the sine of 63. And rounding that to the nearest tenth, we're going to say that T is approximately 13.3, or T is 13.3. Well, Shazam. Now, I'm trusting by this time you know how to enter this into your calculator. If not, raise your hand. We need to look and discuss that. Let's go look at one more where we're going to apply the law of sines when we know angle, angle, side. Oh, okay. Well, here I got another triangle. But I do know there's an angle I know, angle J. I know angle L. And then I know side J, which is 18. Now, while I'm here, like I say, I might would go ahead and just find angle K because it's simple enough to find. So why don't we do that? I'm just going to say that we got 180, total number of degrees in a triangle, minus the 2 we know, 29, minus 25. That's going to equal angle K. So we're just going 180 minus 29 minus 25. And so angle K is going to be 126 degrees. And I'm going to hold that for just a moment. All right, let's see. Well, I know side J, and I know angle L, so let's go ahead and find side L. So I'm going to set this up as the sine of 29, which is the measure of angle J, over 18, which is the measure of side J, equals the sine of L, which is, we're told, is 25, over L side L, which I don't know. And again, we're going to just cross multiply. We got L times the sine of 29 equals 18 times the sine of 25. And to isolate the L, we're going to say that that's going to be equal to 18 times the sine of 25 over the sine of 29. And so L is going to approximately equal, well, 18 times the sine of 25. And we're going to divide that by the sine of 29. And let's see, rounding that to the nearest tenth, I'm going to say that L is approximately equal to 15.7. So here we got 15.7. Let's go ahead and put 126 in here for K, just for fun. All right, I still got to find the measure of side K. That's opposite the angle of K, which is 126. And remember again, I was given both the angle and I was given angle J and side J. So I'm going to set my ratio up again as the sine of angle J, which was 29, over side J, which was 18, sticking with what I've been given. And now I've got the sine of K, which we've determined is 126, over side K. And again, we're just cross multiplying. And I probably would actually eliminate this step. If you see that, if you can visualize that, I would encourage you to do it, save you writing something. So now I got 18 times the sine of 126. That's equal k times the sine of 29. Isolate the k. So k is going to equal 18 times the sine of 126 over the sine of 29. Let's see if we can get an approximate measure for k. All right, so we got 18 times the sine of 126 divided by the sine of 29. And if I round that to the nearest tenth, that's actually 30.0, or just 30. I'm going to write it as 30.0 because that approximate lets me know I probably rounded a decimal in order to get there. Okay, well, that's applying the law of sines using angle, angle, side. And next, we're going to look another way that we can use the law of sines, and that's when we may know angle, side, angle.